this is part of preparation for 309 certificate of qualification. I prepared this chart to simplify the motor diagram. So we'll discuss section 28, motors and generators. First of all, remember that if the motor has its nameplate and full load current is given, then just ignore this full load current and we will use that full load current given in the motor nameplate. If there is no full load current, then we refer these three charts, tables. Table 44 for three-phase motor, 45 for single phase, and table D2 for DC. So if we know the full load current, the next step is to find the conductor size, to find the overcurrent size and overload. So first of all, conductor size. If the motor is of continuous duty, we will multiply full load current with 125%. And if the motor is non-continuous duty, then we will multiply full load current with table 27. There will be different values that I will show you. So that will solve our conductor issue. Next step will be overcurrent, to find the overcurrent. So there are three steps. First of all, if the fuse is time delay, we will multiply full load current into 175%. If it is non-time delay, we will multiply full load current with 300%. If the circuit breaker is given, then we will multiply full load current with 250%. But if this is DC motor, we will multiply 150% with full load current. We use table 29 for this purpose. The last one is overload. Overload, if service factor is equal or greater than 1.15, we multiply full load current with 125%. If service factor is less than 1.15 or unknown, then we multiply full load current with 115%. I hope you understand this table. I just try to make things easier for you. Now I will show you some chapters. Tables 44. See, there's no 600, so whenever it's given 600, we use this column 575. So this is for three-phase motor. Be careful, sometimes we do mistakes. This is synchronous type motor. This is induction time and squirrel cage motor. So just pay attention. Okay, then table 45. Table 45 is a single phase. We have 115, 230 volts. Sometimes they give 208 volt. So for 208 volt, remember this first line. For full load current of 208 and 200 volt motor, increase the corresponding 230 volt motor full load current by 10% and 15% respectively. This is very important. Sometimes we do mistake. If there is 200 volt, 208 volt, we just consider this one. So that will be wrong. Okay. So just pay attention. We need to increase the voltage, current, full load current. So this number one is very important. So this is table. Now there is another table for the motor insulation that I will show 37. So we have insulation type. This is important. All except totally enclosed non-ventilated, and this is totally enclosed non-ventilated. So just remember these values. Okay. Then the table we use 29, that we use for overcurrent. This is the 29. Time delay fuses, non-time delay, and circuit breaker. Okay. Pay attention here, single phase and everything, and direct current. And 27 we use for to find the conductor. If the motor is continuous duty, then straight away we multiply full load current with 125%. But if the motor is non-continuous, then we use these values, whatever will be given. I will give you an example to understand you more correctly. This is an example. Here we have, you see all the motors are 600 volt and non-time delay fuses, totally enclosed fan closed motors. Okay, all conductors are copper, squirrel cage motor. The first motor 50 HP, insulation class A, continuous duty, service factor 1.15. So first of all, the insulation will be class A. Class A in this table 37, I just show you 75 degree. Okay. Then step 2, we need to find motor full load current. There's no full load current in the specification, so we will refer this chart. So if you table, so if we go to table 44, that is 52 ampere. Okay. Next step is to find the value of conductors. This one, conductors. So full load current into 1.25. Why 1.25? Because it's continuous duty. So this is conductor. Next is overcurrent. For overcurrent, this is full load current. We'll multiply with 3 by using table 29. Why? Because this is non-time delay fuses. So we find overcurrent. Now next is overload. Overload, we use at a 52 ampere, we multiply with 1.25. Why? Because service factor is equal to 1.15. So just remember, if it is 1.15 or greater than 1.15, we multiply full load current with 1.25. Another example, I give you this one, motor 3. In motor 3, you can see 20 HP insulation class F, duty short time 5 minutes, service factor is. So this is the insulation temperature, class F is 110, table 37. Next is motor, we use table 44 to find the motor full load current 22 ampere, and then we check the conductors 22 into 1.10. Why 1.10? Because duty short time 5 minutes in table 29 is 1.10. And then overcurrent, this one. Overcurrent is 22 into 3. Okay. Because duty, because all the motors are non-time delay. And the last one is overload. Full load current is 22 multiplied by 1.25 because service factor is 1.25. So these are the examples. Some other motors, you can practice this one also. You can just go, I will just go through this table so that it will be helpful for you. These are different specifications. You can see these are time delay fuses. This just see in bottom on the right side. These are time delay fuses, totally enclosed, 480 volt, not 600 like the other one. Okay, so this is a good chart to practice. Now I give you another example. What is the maximum rating of an overload that is being used to protect a 20 HP 3-phase 575 volt squirrel cage motor? So first of all, we need to find overload. Okay, so this is easy reference. You see, table 44, 20 HP full load current is equal to 22 ampere, and because this is 20 HP with 570 volt, we need to find overload. So we multiply with 1.15 because if the service factor is less than 1.15 are not given, then we multiply full load current with 1.15. Remember? So that's why. So answer will be 25.3. Correct answer. So thank you very much. If you like my video and if it really helped you, please subscribe my channel. Thank you very much.